The operating principle of the design MEMS based on RF capacitive switch is based on the electrostatic actuating. The actuation voltage can be expressed as given, where K is the stiffness of the beam, G0 is the zero bias bridge height, E0 is the permittivity of free space, and A0 is the overlay area of the top and bottom actuation electrodes. From this, we can tell that the actuation voltage will decrease when the actuation area becomes larger. The loss of the membrane can be expressed as given, where X is the signal frequency, Cu is the upstate capacitance, Rx is the resistance of the MEMS bridge, and Z0 is the characteristic impedance of the CPW. The upstate capacitance is where R1 is the capacitance area, TD is the dielectric thickness, and ER is the permittivity of dielectric. From this, we can tell that the membrane loss will reduce when the capacitor area become larger.
Hi, Assalamualaikum. My name is Intan Nurizati binti Azhar. I will explain about MEMS fabrication simulation. A 3D view of MEMS device is from device layout, fabrication process description, and material database. For the layout layer, it has N-2, nitride, and poly1. Next, material database consists of 9 material, which is silicon, aluminium, titanium, tungsten, silicon oxide, silicon nitride, dielectric oxidation, and gold. The value for elastic modular Poisson ratio, density, thermal expansion, coefficient, and relative permittivity for 9 materials shown in the table.
In our MEMS fabrication simulation, there are all 19 steps of process. We use 9 types of material, which include silicon, aluminium, titanium, tungsten, silicon dioxide, silicon nitride, dielectric, gold, and oxidation. Our design is using surface micromachining, where the etching of the sacrificial layer of titanium, tungsten, and gold produce the switch actuator. The type of boundary condition is fixed or also known as bridge, because the contact pads are joined in parallel to support the diaphragm. Referring to figure of final 3D model and final cross-section, the label of B and B bar is referring to the cross-section of the design.
System. First of all, we have to open static structure and insert material that we used in this project at engineering data. Then open geometry and sketch the structure of the proposed switch. Once it is generated success, we can create model. In model, we have to insert material, coordinate systems, and connection, and mesh. So once we have generated mesh, we have to do static structure. In static structure, we can insert analysis setting, fixed support, and force. Then after we have generated that, it is success, and in the solutions, we can find whatever we are finding in this report. For an example here, we have find solution of total deformations. Okay, in the right hand side, this is the geometry space claim. Then after geometry, we have generated mesh. Then after mesh, the solutions, total deformations are the input and boundary conditions.
For this ANSYS analysis, we use force as input and the total deformation and directional deformation as an output. We want to see the different output of this material, where we use the same material and same parameter. So from the graph, it can be seen that gold has the highest for both output, where because gold has a lowest value for the young modulus and highest values for the Poisson ratio. So that's why gold has the highest value in total deformation and directional deformation to compare with the silicon and silicon nitride. So for this slide, I will explain about the MEMS capacitive actuator for campus sustainability. Now, more than ever, environmental issues are becoming especially important. It is almost impossible to deny the adverse effect that our modern lifestyle, full of electronic and fossil fuels, has on our environment. That means that we should do whatever we can to reduce our personal carbon footprint at school or universities. New long-lasting, energy-saving fluorescent light bulbs have been put up around the campus, while RF capacitive switch in classroom and multi-purpose facilities have helped prevent unnecessary lighting usage throughout the campus.
As of today, most of the energy is generated from coal-powered power plants. These plants do generate energy but also pollute the environment by emitting harmful gases in the atmosphere. Improper energy saving impact climate patterns and deplete stores of nature resource. Excessive energy use can harm animal and ecosystem. A smart monitoring of current usage at FTCAN is proposed by utilizing a RF MEMS switch. Smart city technology helps cities save more resources by reducing electricity. They can automate energy consumption data storage and enable RF MEMS switch to improve energy efficiencies. Besides, digitalizing is transforming the global landscape. Beat switch is actuated by biasing a specially set actuations, electrode enhancing DC voltage and RF signal like never been before.